Hello, viewers. We are back again. Yes. And today we want to do laws of indices. Laws of indices are those sets of rules that help us to simplify mathematical expressions that involve power. Let's break it down. Laws of indices, they are sets of rules. Set of rules. That means we must follow these rules to get it right. So this set of rules does something. They tell us on how to simplify. Have you seen it? What do they help us to simplify? To simplify any mathematical expression. The mathematical expression can appear in your physics, chemistry, maths, your pure maths. Understand? Even your normal art courses. These laws of indices are sets of rules, group of rules, numbers of rules that help us to simplify, to make something easy, to simplify mathematical expression. But this mathematical expression is of one kind. What makes it special? Because it must involve powers. Example, are you seeing this number 64? I can simplify it in its lowest term. What does that mean? 2 times 2 is 4, 4 times 2 is 8 times 2, 16, 16 times 2, 32, 32 times 2 is 64. Have you seen that we have simplified this now? We can compress it. When we compress it, what does that mean? You see these two, instead of writing all these, you see these two, you can raise it to a power. How many are there? 1, 2, 3, 4, 5, 6. I write 6 here. So this simply means 2 raised to a power of 6. 2 raised to a power of 6. Now when you see 2 raised to power of 6, it's telling you that you have to times 2 times 2 times 2 times 2 in 6 places. Have you seen it? And when we do this, you see that here, this one, we call it base. Becomes our base number. This is called base. Why? This is called index. Understand? This index, you can call it index, or you call it power, or you call it exponents. You see, they are the same thing. So someone will ask, why are you writing index when you have indices here? Very simple. The singular is called index. Index. While the plural is called indices. Have you seen it? That is why we call it index, because it is just one. Have you seen it? Index. But if it's more than one, you call it indices. Now, what is indices itself? Very simple. Indices is just repeated multiplication. Repeated multiplication. When a multiplication is being compressed. So I'm writing the big numbers, we compress it. Another example is 3 times 3 times 3 times 3 times 3. Let's do it together. 3 times 3 is 9. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 2, 4, 3. Have you seen it? So instead of writing 2, 4, 3, we simply write the base number. What is the base number here? 3. The base number is 3. Have you seen it? That is the number that carries the power, is the base number. Is 3. Then how many times do you have to multiply 3? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3 raised to power 5 will give us 2, 4, 3. While the base number carries the power itself, or the index, tells us how many times you are going to multiply the base number. This is the base number. The 5 tells us now that we have to multiply this 3 into 5 places. Have you seen it? So instead of writing this 2, 4, 3, we'll just write 3 raised to power 5. Have you seen it? That is very good. That is shortcut. Laziness in mathematics. But it's highly helpful in calculation. Makes our calculation to be easier so that we can do other ones. Okay, we have the first law of indices. Okay, multiplication law and product law are the same thing. Understand? And now the law says that when you have the same base, mind you, the same base. I hope you remember what is still base. So if A is raised to power m, then you now have times A raised to power n. Okay, are you saying this one is the base, this one is the base? They have the same base, the same A and A. Have you seen it? So according to law of indices, when they have the same base, then their powers must be added. Am plus n. That is how to do it. Understand? And we can prove it. So how do we prove that? This is a proof of that. If we are given A raised to power 3 plus A raised to power 2 times A raised to power 3 times A raised to power 2, it will give us what? Well, let's do it. Understand? We can say A times A times A. Are you seeing it? How many A's? 3. Are you seeing it? Then we put this times. Then we have to times this A. That is A times A. How many A's? 2. This one is 2 and this one is 3. So when we add together, it becomes what? 1, 2, 3, 4, 5. Are you seeing that is A5? And if we go back to use our law, it is A raised to power 3 plus 2, which equals to A5. Have you seen it? Have you seen it? Yes. There's no magic in mathematics. Understand? If you follow the rules, you will always get it right. So that is a proof to it that this is correct. Understand? I hope you can do it. Yes. Well, let's do another one. If you are given this number, 3 times 3 raised to power 7, what are we going to do? The things we used to do before. Have you seen it? I'm going to bring this out 3 here. This times will become plus for the power. Understand? Remember it's for the power, then you plus it with your 7. So our answer will be what? 3 10. That is the first law of indices. Okay? Okay, now we have come to second law of indices. The second law. And it is called division law or quotient law. Division law or quotient law. It says AM divided by AN is equals to AM minus N. Now when you are given division, the powers must be subtracted. Do you understand? And we can prove it. Okay, let's prove it. If we have A raised to power 5 divided by A raised to power 3, just so simple. You see the number base? They are the same base. Mind you, same base. Understand? Okay. We'll just bring the base, same base, bring one of the base, then you acknowledge your rule. 5 minus 3 is equal to A square. Do you see it? Well, let's prove it. That means A into 5. A times A times A times A. 1, 2, 3, 4, 5. Okay, you see that it's 5 A's. 1, 2, 3, 4, 5. Have you seen it? Then we have the 3 A's. 1, 2, 3. Have you seen it? Very good. Well, let's do our normal division. This will cancel this. This will cancel this. Have you seen it? This will cancel this. Have you seen it? What is remaining? We only have 2. So that is our A raised to power 2. We not write 2 like this. Have you seen that it has proven that rule? Understand? Very good. The rules is consistent and correct. So now we are given this. Can we solve it? You can pause the video and try it. Okay. You bring our base. They are the same. So you keep it here. Then the rule said that division turns to minus for the powers. So I do. So this is 5 raised to power what? That is 4. So simple. I hope it is. Okay. Okay. The third rule is power of power. You see a base raised to a power, and the same base raised to a power is inside brackets and also raised to another power. Have you seen it? A base is raised to a power, and the base with the power is also raised to another power. That's what we call power of power or bracket of power. Do you understand? Okay. When we see something like this, the rule said that we will just write the base, we multiply the powers to get mn. Do you understand? That is, for example, if we have 2 raised to power 2, there's also raised to power 3. What we're going to do is just to write our 2. To write our 2, then we'll multiply the powers 2 times 3. And that will give us 2, 6. Do you understand it? Can we prove it? Yes, there is a proof. Look at the proof. 2 raised to power 2. That means 2 times 2. This means 2 raised to power 2. 2 raised to power 2. 2 multiply into 2 places. 1, 2. Have you seen it? Okay. Now, this 2 into raised to power 2, we have to raise to power into 3. That means 2 raised to power 2. This one is 1. 2 raised to power another 2. 2. 2 raised to power another 2. 3. You understand? 2 raised to power 2. We have done that. Then we have to raise to power into 3. So that means 2 raised to power 2, 1. 2 raised to power 2, 2. 2 raised to power 3. How many 2 was it raised to? 1, 2, 3, 4, 5, 6. That is 2 raised to power 6. Are you seeing? That is the proof. I hope you understand this. Okay? Well, do this one for me. 7 raised to power 5 raised to power 2. Okay? Press your pause. Try it. Okay? We'll not do it. 5 times 2. That is 7 raised to power 5 times 2 is 10. And that is your answer. Thank you. So this is the third law of indices. Another law of indices is the zero law. And it says that any number raised to power 0 is equals to 1. Any number raised to power 0 is equals to 1. Can we prove it? We can. Okay, we'll not have to prove that. If you are given AM divided by AM, are you seeing this? What are you going to do? we see that we are going to have AM divided by AM must be equal to AM minus M, according to the what? Division rule or law. Remember? Have you seen it? Here we have the same basis. We have the same basis and we have the same powers. So when we try to manipulate it, what will happen? You see that this will cancel this to give us what? This cancels this is 1. Abi? 1. You see that A raised to power M divided by A raised to power M is 1. Understand? Because 2 over 2, 2 divide itself, 2 divide, this 2 will divide this to give you 1. Have you seen it? So here is 1. Have you seen it? Here is 1. Why? It is equal to what? A raised to power M minus M is what? 0. Have you seen it? That is a proof that 1 is equal to A 0. Remember in mathematics, the left hand side must be equal to the right hand side. Have you seen it? This, when we manipulate this, we get well. When we manipulate this together, that means this and this is the same. Have you seen it? That is the proof that A0 is equal to 1. So any number they give you, whether 1000 0 is equal to 1, whether 27360 is equal to 1. Understand? Because it's trying to tell you that their powers are the same. The zeros are telling us that the powers are the same. That when you minus it, understand, it will give you 0. And when you divide this, it will give you 1. So that is it. Understood? Thank you. So we come to number 5. Number 5, we have the negative power. You understand? Negative of power, when a base is raised to power minus power. Understand? The base will, the answer will be the reciprocal of the base. Then the negative power will turn to positive power. You know what is called reciprocal? Reciprocal is inverse of any number. If I ask you to give me reciprocal of 3, you just tell me 1 over 3. The inverse of 3. Understand? Or what you use to times that number to give you 1. This 3 times 1 over 3, you see that it give me 1. That is reciprocal. Understand? Reciprocal is always opposite. Understand? Or reciprocal of 20 is what? Just 1 over 20. Do you understand? The law of the index here is this. That this base, you write the reciprocal. While the minus changes to positive. The minus power will change to positive power. Do you understand? Understand? And can we prove it? I know that's what you're saying in your mind. Can we prove this? We can. By God's grace. Okay? Proof. So how do we prove this? Okay? If we are giving A raised to power 4 minus 5. Have you seen it? That will be equals to A4 divided by A4 divided by A5. Do you understand? You want to manipulate this to get this law proven. So if you're giving A raised to power 4 minus 5, remember it is also A raised to power 4 divided by A5. Remember that division is minusing. Understand? This is division, this is minusing. It's the same thing. I hope you not forget. But when we are giving something like this, see that we have A4 minus 5 is what? 4 minus 5. You can use our number line in case if you are not used to, you have not learned this. You can use our number line to solve this. Abi? 4 minus 5. For those that are confused, I don't know what to do with this. 4 minus 5. The 4 tells us the starting point. We have done number line, you can go there and see how it is done. So the 4 tells us where to start. We are going to start from 4. Understand? The minus tell us we are going to go left. Minus, because that is where minus is. Understand? We are going to go left. Then the 5 tells us the step. So you go first step. 1, 2, 3, 4, 5. Are you seeing it? You stop at minus 1. That means this is minus 1. So how do they see that a minus 1 will now be equals to this a times a times a times a. How many a's? 1, 2, 3, 4. Very good. All over a times a times a times a times a. Are you seeing it? So we'll have this a will cancel a. This a will cancel. This a will cancel this a. This a is cancel. How many a is remaining? Are you saying that what is remaining is just 1? When there is no number, it means 1. So this is 1. So a minus a raised to power minus 1 just means 1 over 8. Have you seen it? 1 over a. We have cancelled the 4 a's. It's remaining a. You cannot. This thing cannot be just a. You cannot say the answer is a. It's not just a. The a is the denominator. The numerator is 1 because when this a cancels a is 1, 1, 1, 1, 1. So 1 times 1 times 1 times 1 times 1 is 1. Have you seen it? While this one a times 1 times 1 times 1 times 1. A times 1 is a times 1 a times 1 a times 1. So the answer is 1 over a. I hope you are not confused. I hope you are not confused. Very good. So with this we have proven that any power raised to power minus 1 will give us 1 over the number. Understand? Have you seen it? Then the power becomes positive. The power becomes positive. 1. Very good. We have other proof. We have another proof if you want. Okay, another proof is this. If you are given AM divided by AN, this is what we are usually giving. But this time around, our M is 0. So we are giving A0 all over AN. Are you seeing it? And they ask us to solve this. What are we going to do? So this is our A0 over AN. According to our division rule or the law of division, we'll have that our A0 minus N. So the division becomes minus. Do you understand? Very good. So having given all this, what do? We'll not say A0, remember, if the division turns to minus, our A0 is still 1. Do you remember that? Very good. So our I0 is 1 over AN, which is equal to our A0 minus N is what? Minus 10. Have you seen it? That is another proof that any base raised to power minus any number must be the reciprocal with the power turning into positive. Do you understand? Very good. Okay, now, if you are asked to solve 3 raised to power minus 2, you are asked to solve this 3 raised to power minus 2. From the rule, we say that the base will become a reciprocal. Understand? Then we say that the minus 2, the power will turn to positive. That is, just follow the rule. Understand? So we cannot leave it like this because we can simplify this a bit. Yes. So we'll now have 1 over 9. And that is our answer. Okay, now we have another rule called fractional index. Yes, fractional, from fraction. fractional index. This is where a fraction becomes a power. Do you understand? Okay, and the rule says, you see, n, this n over m, this is a fraction. And here is the numerator, while here is the denominator. Have you seen it? So, according to the rule, it says that denominator will become the roots. Roots. We have square roots, cube roots, fourth roots. The denominator will become the roots, while the numerator will become the power. Do you understand? Okay, now we have to prove that a fraction, that any base raised to power a fraction must be equal to the square root or the root of that fraction. We have to prove this. Okay, if I ask you 2 raised to power is what? You can simply tell me that it's 2 times 2. Have you seen it? Now, if I ask you 2 raised to power 1 is what? You can simply tell me that it is 2. But now, if I ask you 2 raised to power half, it will be what? So you see, we can express 2 raised to power 2 as 2 times 2. Understand? We can express 2 raised to power 2 because it's 2 times 2. We can express 2 raised to power 1 because it's just 2. Understand? 2 into 1 place is 2. But we can't express 2 into half. Understand? There comes our logical manipulation. So, we don't know what 2 half is. But we do know what 2 raised to power half times 2 raised to power half. We do know what it is. From our multiplication law or product law, we have that these two, when we raise to power the 2 halves, that's why we want to work out this. We'll see that we're going to have our this thing to be 2 raised to power 1. Why is it 1? Because half plus half is equal to the same denominator, so 2 over 2 is 1. Do you understand? So that is 2, 1. I hope you're not confused. Very good. Okay, now, so we'll now ask ourselves, what are you going to tie together to give us these 2? Do you understand? If this is 2 and we are equating this to this, but we need to simplify this, what are we going to tie together to give us this so that we know the value of this? What are you going to do? Then we're going to think, what are you going to tie with another to give you this? So another mathematical expression that can give us these 2 back is, example, when we have square root of 3 times square root of 3, it will give us 3. How? Because square root of 3 times square root of 3 just means 3 times 3, 9, but still the square roots. So the square root of 9 is 3. Do you understand? So the only thing that can give us 2 is the square root of 2. How? The same thing. Because square root of 2 times square root of 2 will give us 2. Why? Because 2 times 2 is 4. Square root of 4 is 2. Have you seen it? So the only way we can express this to get 2 is square root of 2 times square root of 2. Have you seen it? So what is it telling you? It's telling you that this square root is equal to this. 2 raised to power half is equal to the square root of 2. 2 raised to power half is equal to square root of 2. 2 raised to power half is equal to square root of, because this times this will give you 2. The same way, this times this will also give you 2. So it is proven that this thing means square root of 2. I hope you understand it. Very good. Can go back and check it again. Understand? Very simple. So this thing means square root. This thing means square root. So that because when you tie it together, it will end up giving you 2. Okay. Now we have come to the end of the laws of indices. I hope you grabbed something. I hope everything was well explained. The proof helped you to know the reason why it was, what was, the things you see, we are the way they are, understand? It was not just magic, they are just logical, mathematical expression. Now we have some exercises. We'll do some and leave some, understand? Yes. And these exercises are highly important because you come to say that when they ask you questions, they will combine the laws together. Some expression will have combination of negative power, power to power, multiplication, or division. In any way it comes, just follow the rule. You will never fail it. Thank you. Okay. No, you know it already. That is 6 minus 5. Because of the second rule tells us what to do. That AM over divided by AN is equals to AM minus N. Obviously, because the 7 6 minus 5, that is equals to 7 1. That is equals to 7. Do you understand? That is for number 1. Then for number 2, we have these 3 things. We don't have to express this one in. We don't have to express it in reciprocal. Though, if you do, you still get the same thing. Understand? So this is just 8 plus, because the 2 is the same thing. This one is minus, so you acknowledge the minus 3. Understand? So with that, the answer will be what? 3. 8. You know that plus minus will give us minus. Plus minus minus will give us minus. So this one becomes 8 minus 3. So this becomes raised to the power 5. I hope you get it. Okay? So the third one, x over 5 times x over 5. Just simply s times s is s squared. All over 5 times 5 is 25. For this one, you can pause the video and try to solve it. Yes. Just pause your video, try to solve it. Understand? Very good. Okay, now 9 raised to the power 1 over times half all over 27 2 over 5. Please, when you have something like this, just look at these 2 numbers. Do you see that you can express them in a simpler base? Yes. If you see a bigger base that can be expressed in an index form, please express it before you solve. Listen now, we can simplify it to mean 3 raised to power 2, then minus 1 over 2, all over 3 raised to power. Now we have 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So that is 3 raised to power 3. 3 raised to power 3. That is 27. Then we put a bracket 2 over 3. Okay? So you ask yourself, why do we put it in brackets? We put it in brackets to clarify things. Do you understand? Very good. Okay, now, having said that, what are you going to do? See that 2 can divide 2 to have 3 raised to power minus 1. While this 3 can divide 3 to also have 3 raised to power 2. Is it faster? Remember that 3 raised to power 1. Remember that 3 raised to power minus 1 simply means 1 over 3. Then remember we still have this power. 3 raised to power 2 now becomes 9. Have you seen it? So what does that mean? According to a mathematical rule, when we have 1 over 3 divided by 9. It will equal to 1/3 times, you put in 1 here. This one will go up and 9 come here. 1/9. Abi? Okay, you see that our 3 raised to power minus 1 will become 1/3, as we say, and this one becomes 9. So according to our operation, mode of operation, we have that 1 divided by 3. 1, the fraction 1/3. Now divide, this one means divide by this 9. This has to change. It becomes 1/3 times 1/9. That means 1/3 times 9 is what? 27. Here we'll have our answer will be 1/27. That is our answer. Now we want to solve this. Remember the tip or the expo to get it right. The bigger bases, we can simplify it to simpler bases. Just look at the base they gave you. Check whether you can simplify it. Then you can work with the simplified base. So this one we can simplify it. The 4 and 16 are simplifiable by the same base. Okay, here we have 2 raised to power 2. Because 2 raised to power 2 will give us 4. Look at this minus. Please be careful. Make sure that your minus, you don't exempt them. After solving, go back and check and recheck. Understand? Okay? So now, how many times are we going to raise 2 to give us 16? 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. You see, we have 2 raised to the power 4 will give us 16. We have 2 raised to the power 4. Then put that power. We said that this bracket helps us to clarify things, for things to be clarified. Understand? So that will not make mistake, don't make mistake. Understand? Oh, very good. And see, this one is 2 raised to the power 1. Also to put this one in brackets. Understand? I see it. It's very simple. Understand? You see that we can now manipulate this, divide this is 1. 1 times minus 1. Please don't forget this minus. We have 2 minus 1. 1 times minus 1 is minus 1 times, we have 2. This will cancel this. So we have 1 times 3, that is 3. So 4 cancel 4. So we have 2 raised to power 3. Are you seeing 3? All over, we'll come to this. And this can cancel this. So we have 2 raised to power 1. Okay? So, what do we do? Bring it together. You see, all of them are in the same base now. So now I can manipulate the powers. Understand? Using their rules. Here we have, you see, 2. This is minus 1. And this is times. Multiplication law. Understand? You see this times. That means the powers must be added. Understand? So we add it to this 3. Have you seen it? Okay, now, this 2, I said this is over. That means this is divide. Anything that is down here, while coming up, the sign must change to minus. Do you understand? If it's minus already, the minus will change to plus because minus is plus. Do you understand? Remember our division? I hope you have not forgotten that when you have something like this, divide by something like this, will be equals to A4 minus 3. According to the second rule. So this one will come up. But will come up as minus 1. Why is it coming up as minus 1? Because of this division rule. Have you seen it? So having said that, we'll now have 2 minus 1 is what? Or minus 1 plus 3. But let's just minus. Let's collect the lightest of the signs. Minus 1, we have plus 3. What does that mean? That is minus 1 is minus 2 plus 3. That is equals to 2. 3 minus 2 equals 1. So the answer is 2. That is the answer. Just follow the rule of mathematics. minus minus will give you plus. But because two of them have minus, the answer will have minus. 1 plus 1 is 2. Minus minus is not times. Later we'll still do them. Understand? In our next video, we'll talk about the signs. Understand? So for now, you can use your number line and locate it to see that you get this particular thing. Do you understand? Very good. So minus 2 plus 2 will give us 2 raised to the power 1, which is equal to 2. Very easy. Understand? When you practice them, it will enter. If you follow it and you watch it, it will be so sweet. But if you do not practice it, I'm sorry to tell you, you'll be disappointed. Practice them. Understand? I'll give you some exercises. Drop in the comment section. Let me see what you get. Understand? You marvel. That is so simple. Understand? Okay. We have this one. See, 8x is equals to 32. So what do? We simplify. 2 raised to the power what? 3x. Because 2 times 2 times 2 will give us this. Very good. How many times are we going to raise 2 to give us 32? Mind you, some people will say, can't another number go in? Can we use another number? Yeah, there's some number that will use a number, but remember we are looking for the simplified one. Understand? 2 into this. Understand? For now, it's only 2 that can times itself many times to give it 32. I don't think there's another number that can do that. 3 times 3 times 3 cannot do that. 4 times 4 cannot. Understand? So it's 2 that will do that. Understand? Very good. Be careful. Your examiners are intelligent and logical too. You cannot give you something that is on this level. Understand? Or logical. Very good. Well, look at this one. 32. It's 2 raised to the power how many? 5 times. So now, when the numbers, the bases are the same. Be careful. When the bases are the same, you equate the powers. What we have here, we'll now have, since we have 2, 3x equals to 2, 5. We will not ignore this thing. And we'll do 3x is equals to 5. That's what we mean that it's equating power. Equating powers. So now, making s the subject of the formula, we divide both sides by 3. So our s is equals to 5 over 3 is equals to 3 into this is one whole number what? One whole number 2 over 3. And that is your x, that is your value. Do you understand? Okay, how about this one? I hope you can do it. Just divide and I'll do it for you. Try. Just try this one. So easy. Just divide. I'll give you a clue. Divide 72 with 2. Then you manipulate these ones. Understand? After submit, I'll see it. I'll see your answers in the comment section. And you get my answer too very soon. Understand? Okay. Thank you so much. More exercises to try. So this is very simple. So this and this two will be the exercise you will do. Understand? You can do it. Don't marvel. It's the same thing. Understand? You'll be surprised at what you can do. Understand? Just ask God to help you. Please, if this is helpful to you, or you use it to refresh your memory, is beneficial to you, please do like, do share, do follow, do subscribe, do write something in the comment section, please. Thank you. Bye.